Welcome to this chapter of our CUDA Developer Tools video series. My name is Jackson Marusars, and in this video, I'll present an introduction to NVIDIA Nsight Compute, including some setup tips and key features for performance analysis. Nsight Compute is the best tool for understanding the performance of CUDA kernels as they run on a GPU and how the kernels are utilizing the underlying hardware. There is a standalone GUI that can be used to configure and run profiles, as well as analyze the collected data. It supports both local and remote targets. There is also a command line interface that can be used for profiling or analysis, and results collected with the CLI can easily be opened in the GUI. The collected performance metrics come from various sources, including hardware performance counters and code instrumentation. In order to collect all of this information, Nsight Compute has a sophisticated replay mechanism that allows it to save the GPU state before a kernel executes and restore it afterwards to repeat the execution and collect more data. This is the most common method of using Nsight Compute, but there are additional modes to replay user-defined ranges or rerun the entire application, which doesn't require any saving or restoring. You can select the replay mode in the GUI or using command line flags. A couple of quick setup things. By default, NVIDIA drivers require elevated permissions to access GPU performance counters. On mobile platforms, profile is root or using sudo. On other platforms, you can either start profiling with root or sudo, or enable non-admin profiling. For details on getting that set up, see the documentation. If you run into an error, the error message should have a link to more info on what to do. Also, in order to get source-level details about performance metrics, make sure you are using the line info flag during compilation to generate debug line information. Note that you want the line info, but you don't want a debug build with optimizations turned off. We want to profile a workload's performance as close to its normal execution as possible. The first step is to configure the connection dialog with information about the target application and what type of profile activity you want to run. To run a profile on a remote target, configure the target hostname, application to profile including arguments, and remote working directory in the Remote Launch tab of the Target Platform section of the connection dialog. This will use SSH to connect, copy necessary profiler files if needed, launch a profile, and automatically copy results back to the host, where you can analyze them in the GUI. This is a very common use case for profiling workloads running on remote clusters or lab machines without graphical interfaces. After you configure the target, you'll want to choose the profile activity. The non-interactive profile will run your application automatically with the settings you have defined, collect the data for your kernels, and display the results. The interactive profile has a built-in CUDA API stepper that allows you to walk through the application as it is running with the ability to break on any API call and inspect various CUDA application environment details. You can break before a kernel is called and configure what data to collect right before the kernel runs. There's also a system trace activity that runs a trace collection based on Nsight systems. It gives an overview timeline of the entire application, including CPU and GPU activity, but won't include details about performance within a specific kernel. You can use this to identify which kernel you want to dig deeper into. Finally, there's an occupancy calculator that helps you compute the multiprocessor occupancy of a GPU for a given kernel. It allows you to model different resource constraints like register counts and shared memory size to determine how well a given kernel will utilize the available resources. Let's look at some of the configuration options for a non-interactive profile. Many of these are applicable to interactive profiles as well, but in that case, they will be selected at runtime when a kernel of interest is encountered. One thing I want to call out is the prevalence of hover text in the GUI. You can mouse over almost anything you want to know more about to see a pop-up with more details. In the Common tab, there are options for how the application will be profiled and where the results are stored. There's also a super valuable box at the bottom that contains the command line to run the profile that's currently configured. You can just copy and paste this to another machine if the GUI isn't available there. That way, you don't need to waste time learning all the CLI flags. The Filter tab has options for configuring which kernels to profile. This can be based on kernel names or IDs, including regular expression matching, and can additionally be filtered with skip counts or device filters when multiple GPUs are available. The Metrics tab is an important one, because that's where you will select what profile data you want to collect. The metric sets are a good place to start. They are predefined groupings of metrics with different granularities for different purposes. The detailed set is the default, but if you want just an overview, you could select the basic set, or use the full set for even more information. Note that the more metrics that are included in the set, the more profiling passes will be required, which could lengthen the profiling time. There's also the ability to choose metrics based on metric sections and rules. These sections and rules are how Nsight Compute displays the data, and we will touch on that a bit more in a little while. The Sampling tab has a few more advanced configurations that you probably won't need when you're just starting out. The Other tab is a mix of the remaining configurations. A couple I want to call out are the Enable and Disable profiling options that are used for additional profiling control, and the Import Source option that will import source code into your result. That way you can share it with a colleague and they can see the performance metrics resolved to lines of source code without needing access to the source files. Once your collection is configured, you can click the Launch button or copy the CLI to run the profile. After the profile is completed, Nsight Compute generates a report that contains one or more profiling results. Each result corresponds to a kernel that was profiled during the run. The report contains multiple pages selectable by a drop-down. On the summary page, you'll see each kernel result and some basic information, including its runtime, how many performance rules were triggered, and some speed-up estimates for fixing them, where applicable. Double-clicking a row will take you to the Details page. This is the detailed profile information for the selected kernel. You can change the kernel to analyze from the result drop-down. The Details page has multiple sections for performance data, including warnings about performance rules that exceeded a threshold and guidance on how to fix them. The last page I want to mention is the Source page. This is the page that will contain source-level profile information as long as line table information was generated at compile time. You can see CUDA, C, PTX, and SAS, including correlated lines, highlighted when you select a statement in the source code. The Source page helps you determine exactly where in your code the issue is being encountered and where you need to make changes. There are a few other pages available as well, including a raw data page and a session page with information about the profile run. Hopefully that gives you a quick introduction to Nsight Compute and how to get started. The kernel profiling guide linked below is a valuable resource for learning how to use Nsight Compute, and I recommend it to every new user. And don't forget to check out the other videos in this series and the resources we have available from the Nsight Compute homepage. Thanks for watching.